Hello everyone, welcome back to the course on Electrical and Electronics Engineering. In this session we are going to see about Kirchhoff's voltage law and Kirchhoff's current law, that is KVL and KCL, and how they are applied to solve the electrical problems. First let us see about Kirchhoff's current law, that is KCL. This law states that the algebraic sum of the currents meeting at any junction or a node in an electric circuit is 0. That means algebraic sum of currents, if you see the node O, we can see that sum of currents is I1, I2 is leaving the node, so we represent by negative sign. It's entering, I3 is entering, so plus I3 minus I4 plus I5 equal to 0. This is the algebraic sum of the current meeting at a junction is 0. Or you can say in the other way, the sum of current flowing towards any junction in a circuit is equal to sum of currents flowing away from that junction. Or in simple words, sum of incoming currents is equal to sum of outgoing currents. What are the incoming currents? I1, I3 and I5 are incoming. I2 and I4 are the outgoing currents. So we can state in either way. Now let us see about Kirchhoff's voltage law. So for this, let us consider a circuit where a closed circuit where there are two voltage sources and two loops are available along with the three resistors. Okay. So this statement states that in any closed circuit or a mesh or a loop, the algebraic sum of all voltages taken around, okay, is 0. Or we can say the other way, the sum of voltage drop is equal to sum of voltage rise. So first let us see how this KVL law is applied in this circuit. So in this circuit we can say that there are two meshes, okay, and we have to mark the current flow across each of the meshes. We name the meshes A, B, C, FA, this is one mesh, and another mesh is C, D, E, F, C. Okay, the current in each of the mesh we assume at clockwise. Okay, so that the analysis will be easy, and I1 is always chosen greater than I2. And the next step we have to mark the, since the voltage sources are known, the longer horizontal line here represents positive terminal, shorter one negative terminal, as we saw earlier. So based on this we mark the terminals of resistor. So since it is positive, R1 entering terminal is positive, leaving terminal is negative. Similarly R2, R3. So in the next step we are going to apply the KVL. Okay, the algebraic sum of the voltages across any of the mesh in a circuit is 0, right? So we first apply for the first mesh A, B, C, F, A. So if you apply here, what is the current entering? I1. So Kirchhoff voltage law states that I1 into R1, okay, plus I1 into R2, R2 into I1 minus I2, since there are two currents that are possible to flow in this common junction. So see here, I1 minus I2 into R2 minus here V2, since it is entering the negative terminal, equal to 0. So in the same way we have to write for the mesh 2 also. Let us see here, if we start from here, I2 into R3 plus V2, so it is entering here, minus R2 into I2 minus I1 equal to 0. Okay, this is the second equation. So since voltage and the resistance are known quantity, we can solve these two equations to find the unknown current I1 and I2. Let us see how the same can be used for solving the problem given here. So they have asked to apply KVL and find the current in each resistor. So as we saw earlier, there are two currents that are flowing in two of the meshes, I1 and I2. First let us mark the current and the direction clockwise, and we mark the terminals of the resistor positive and negative for the analysis to be easy. Now when we apply the KVL for the mesh 1, we can see that 5 into I1 plus 2 into, since there are two currents flowing here, I1 minus I2, since I1 is larger, right, I1 minus I2, since it's entering the negative terminal, minus 10 equal to 0. Similarly, if you could see here, 10 I2 plus 50 minus 2 into I1 minus I2 equal to 0. So if we solve these two equations, we will get the current values I1 and I2. And we can see that if the current value here I2 is negative, that means that our assumption direction, that is clockwise direction, is wrong. So we have to change into anti-clockwise, since the current cannot be a negative value. I1 is a clockwise, I2 is anti-clockwise. So we are representing okay, the current I1 that we have found earlier, 0.25 clockwise from the left to right, and anti-clockwise right to left. And this is the I3 value. Okay, so if you compare with the circuit R1, R2, R3, I2 is the current flowing across R3, but we need to find the current across the R2 also, which is going to be the sum of these two currents. Okay, one of the current is I1 and another current is I2. So if you see here, both the currents are entering into the terminal, so we have to add the current as per the KCL, Kirchhoff's current law. If we add, we get this current, and this current is going to be a downward direction. Okay. For the same problem, now we are going to apply the mesh analysis and find the current in each of the resistor. The same problem we are going to take. First we assume the direction of current in two meshes, I1, I2, in clockwise, and mark the terminals, okay, in all the terminals based on the voltage source. The entering terminal of resistor is positive, leaving terminal is negative. Similarly, the other two. From Ohm's law, we know that V equal to IR. So RI equal to V. We can write this. We are going to represent in a matrix form. So the resistor is going to be, the size of the R matrix is going to be the number of meshes cross number of mesh. How many meshes are there? There are two meshes, so it's going to be 2 cross 2. So how will you write a 2 cross 2 matrix? R11, R12, 21 and 22. And the size of I matrix, there are two currents, so it is going to be size of mesh cross 1, so it's a vector. So I1, I2 column vectors, that is equal to size of V matrix is nothing but same, similar to the current. So it is V1 and V2. Now we are going to find the elements of the resistance value. Okay, the elements. If you see here, the diagonal elements is going to be always a positive, and off diagonal elements, they are going to be positive, okay, if both the currents are in same direction in the common resistor that we consider. Okay, in the middle resistor, this is a common, right, 2 ohms, and it is going to be negative if the currents are in opposite direction. Okay, we know that we are going to assume the mesh current in clockwise, and our off diagonal elements will always be negative. Okay, will always be negative because we consider the current in the common resistor. If you see the current, it is I1 is coming from top to bottom, and I2 is going from bottom to up. Since we assumed clockwise, it is always going to be negative only. So let us find the values. R11 is the total resistance in the mesh 1, 5 plus 2, that is 7. Similarly, R22 diagonal element is total resistance in mesh 2, 2 plus 10, 12 ohm. And what about this off diagonal element? They are going to be same, and it is nothing but the common resistor value with the negative sign, minus 2 ohm. And voltage sources V1 and V2, if you could see here, if you assume the mesh current and actual current, okay, positive to negative, both are same, mesh current and actual current are same, voltage is negative. If not, voltage is voltage is positive. If not, voltage is negative. Let us see how to find the voltages V1 and V2. Okay, so if you see the circuit, we can understand that there are two voltage sources. In the first voltage source, the current is entering in the negative terminal, so we have to take it in the opposite way, that is positive voltage 10 volt, while here it is entering the positive terminal, so take it in other way, so minus 50. So if you rewrite this matrix as an equation, so take the first row and this first column, if you multiply and sum, 7i1 minus 2i2 equal to 10 minus 2i1 plus 12i2 equal to minus 50. Solving these two expressions, we can get the values of current i1 and i2. If you notice that i2 is a negative value, which indicates that our assumption both the currents in clockwise direction is wrong, so we have to change the direction of i2 since the current value cannot be negative. So i1 is clockwise, i2 is anti-clockwise. So if you want to this is i1 and actually we have found i1 and i2, right? We have to find the current that is flowing across the R2 also. So when we compare this circuit with this original representation R1, R2 and R3, we have found I1 and I2, but the current flowing across R2 is the combination of I1 and I2, right? So here both the currents are, if you could see, both the currents are entering into this terminal, so it is a addition of these two currents, okay, IR1 and IR3. Now let us see one more problem where there are three meshes. Okay. In this problem, we are supposed to apply the mesh analysis to find the current and power dissipated in each of the resistors. Totally there are 1, 2, 3, 4, 5 resistors are given. 5 resistors are given. We have to apply the mesh analysis to find the power dissipated, and that is a single voltage source only. Now by using the mesh analysis, we assume in three meshes. Okay, first write the meshes with letters A, B, C, D. Okay, neglect the E, F, G, H, I. Fine. Now we assume I1 in the first mesh, I2, I3 in clockwise direction. So considering the first mesh A, B, H, I, A, we can see 5R1 applying KVL. We can see that 5I1 plus 30 into I1 minus I2 minus 100, because it is entering the negative terminal, equal to 0. So simplify to get the first equation. Now for the second mesh, if you see BCGHB, current starts to 10 I2 plus here 10 I2 minus I3, okay, minus 30, it is entering the negative terminal, minus 30 into I1 minus I2, always I1 is greater, okay, greater than I2, I2 is greater than I3, in that way. So if we simplify, we get the second expression. Considering the third mesh CDFGC, what happens? 20 I3 plus 10 into I2 minus I3 equal to 0. We get three equations, right? After solving these three equations, we get the current I1, I2 and I3. Okay, I1 is a current flowing across 5 ohms. I2 is across 10 ohms. I3 is the current that is flowing across this 20 ohms. But we are supposed to find the current across 30 ohms and this 10 ohms, this branch also. So here 30 ohms means I1 minus I2 we have to find. Here in across 10 ohms, what is the current? I2 minus I3 we have to find. Applying the power formula, we have three formulas, right? V into I, V square by R, I square R. Here we know the current value, so I square R. Using these formulas we can find the power dissipated across the individual resistor. First find across 5 ohm, so I square is 6.364, this I1 square, R value is 5. Similarly we can find for other 4 resistance what is the power dissipated based on the current value. Okay, each current and its corresponding resistance, using this formula we get the power dissipated. The same formula we can same problem we can solve it by using the matrix method. For this we have to, since there are 3 meshes, the size of the R matrix is going to be 3 cross 3. Okay, by using the Ohm's law we write Ri equal to V, right? We have 3 currents and 3 voltages. Now if you apply, if you see the diagonal elements, it is going to be the sum of the resistance in each of the meshes. So 5 plus 30, 35, 30 plus 10 plus 10 ohms, 50. Here in the third mesh 10 plus 20 is 30. Okay, if you see R12, it's going to be the resistance common in mesh 1 and 2. So we are going, off diagonal elements are always 0, right? So minus 30. So same repeats here. If you could see here 2 and 3, that is R2 3, it's minus 10. Same repeats here. I1, I2, I3 we can write, and that is a 1 voltage source. Since entering is negative, we write in the positive manner. Other V2 and V3 are 0. If we solve these expressions, we get the currents. From the current we can find the current across the individual resistors, and from the power relationship we can find the power dissipated across each of the resistors. Let us see about mesh analysis with the voltage and current sources. If in a circuit where both voltage and current sources are given, the first method is to follow the KVL method. Another method is there where we have to apply the source transformation and then apply the mesh analysis. And here we have to note that if the load where the current, voltage or power is asked, okay, where load is the internal resistance of the current source, if the load is the internal resistance of the current source, we have to solve only by the method 1, that is KVL method. Okay, let's see how these are applicable in solving the following 2 problems. So in this circuit they asked to find the power supplied by 2 volt source. What is the power supply? Okay, first what we are going to do, we are going to use the method 1, KVL method. For that you have to take the circuit, draw the direction of, mark the current, okay, draw the direction of current clockwise, mark the meshes A, B, C, D, E, F, G, H, and we have to see the meshes. By seeing the mesh, in the third mesh we can easily identify the current through the mesh is 16 ohm, I3 is 16. Okay, so we are going to consider only 2 meshes, I1 and I2. The first mesh, if you apply the KVL, so sum of the voltage drop equal to sum of the voltage rise, right? Or the algebraic sum of voltage across the mesh is 0. So 10 into I1 plus 2 into I1 minus I2 is the current flowing here, minus 2, it's entering in this term, right? Minus 2 equal to 0. So if we simplify we get the first equation. Similarly for the second mesh, if you apply KVL, 5 into I2 plus 3 into I2 minus I3 minus 2 into I1 minus I2 equal to 0. So solving the first and second equation we get I1 and I2 value. They ask us to find the power, right, supplied by the 2 volt source. What is the formula to find the power supplied by 2 volt source in terms of voltage? V power equal to voltage into current. So we have found the current in the first mesh, right? In the 2 volt supply, what is the current flowing in this mesh? I1. So P1 equal to V1 into I1, that is 2 volt into 1 ampere current, we get 2 watts. The same problem can be solved using source transformation method, where the current source in parallel with the resistance can be replaced by a voltage source in series with the resistance. Okay, so the resistance is 3 ohm. Since the direction of current is from top to bottom, so negative sign here, positive sign here, where the tail arrow head is there positive sign. So mark the direction of current I1, I2, and you can write the matrix equation for the R11 value, which is the total resistance in the first mesh. 10 plus 2 it's 12. R22 diagonal element here, 2 plus 5 plus 3 it is 10. And off diagonal elements are negative because we assume both the direction in same. Okay, so what is a common resistor here? -2, that is -2 we represent. I1 and I2, that is equal to 2 volt in for the first mesh. It's entering the negative terminal, right? 2 volt. Here also entering the negative terminal, so plus 48. Solving these two expressions, we get I1 and I2 value. From that we can find power across this 2 volt source. So V1 into I1, that is 2 watts. So let us see one more problem where for a given circuit they ask us to find the voltage across 1 ohm resistor. Since load is a 1 ohm resistor, we should not use the source transformation method. So what we have to do, we cannot use the source transformation, keep the current source as it is. Mark the direction of current in the first mesh is I1 clockwise, but here since the direction is given, it should be anti-clockwise, I2. Next we apply KVL. So in the first mesh, 3 into I1 plus 1 into I1, since both the current are entering the same terminal, I1 plus I2 minus 4 equal to 0. Okay, for the second thing, I2 is going to be what? 1 ampere only. So solving these two expressions, we get I1 and I2. Okay, the current across the 1 ohm resistor is going to be the sum of both the current I1 plus I2. So add both I1 and I2 value. I1 is 0.75, I2 is 1. So 1.75 is the final answer. So we cannot apply source transformation since load is a 1 ohm resistor. Now we are going to see how to use nodal analysis or node voltage method or KCL, that is Kirchhoff's current law method, to solve the following problems. So in this circuit we are supposed to find the current flowing through all the resistors. There are almost 5 resistors. We need to find the current flowing them through the nodal analysis. So the first step, already the nodes are marked. If not, we have to mark the nodes. This is one junction and this is another junction B, and these are 2 junctions at the ground potential. At node A, what are the currents that are leaving that particular node? Okay, so it's I1 current, here I2, I3. Similarly at node B, I4, I5 and I6. So first step, we have to mark the current. Then what we need to do, we need to mark the other junctions. So here, 4 volt is there, here 6 volt, and these junctions are 0 volt since it's at ground potential. First step, we are going to apply the KCL at node A, Kirchhoff's current law at node A. So sum of all outgoing currents will be 0 as per this law. So I1 plus I2 plus I3 equal to 0. From Ohm's law we know that I equal to V by R. So I1 is nothing but VA minus 4 divided by 5. Similarly I2 is VA minus 0 since it's at ground potential by 15 plus VA minus VB by 10 ohm equal to 0. After taking LCM and simplifying, we get this equation. Similarly, apply KCL at node B. So I4 plus I5 plus I6 is equal to 0. I4 is nothing but VB minus VA. Wherever we are taking the junction, that junction potential only is higher. So VB is greater than VA. VB minus VA by 10, VB minus 0 by 8, VB minus 6. Since it's at positive potential, VB minus 6 by 12. Taking the LCM and simplifying, we get the second equation. Solving these two equations, we get the node voltages. Once the node voltages are known, we can find the current through the individual resistor. So current across the 5 ohm resistors is nothing but current across the 5 ohm resistor is nothing but VA minus 4 divided by 5. So we know what is VA, substitute and get the value of current. Since it's a negative value, actually the direction of current is from node A to here, so left to right, so light to left. But since it's a negative value, we have to change the direction of current from left to right. So now we will find the current across 15 ohm resistor, that is VA minus 0 by 15, right? And here the direction of current is downwards. Current across 10 ohm resistor is VA minus VB by 10. So here the direction of current is from left to right. Similarly, across 8 ohm resistor and 12 ohm resistor, we can find the current value. If it's a negative, we have to change the direction that we assumed. Okay, what we assumed, from that we have to change the direction. Now let us see one more problem. So to have a better understanding, here actually one current source is given, nodal analysis with current sources. In previous problem we saw with the voltage source, now we are going to see with the current source. So if we are supposed to find the node voltage VA, VB, and we have to find the power absorbed by each of the resistor. Actually 3 resistors are there. How much power is absorbed we are going to find. First step, applying KCL at a node A, we have to mark the currents that are living at this node: I1, I2, I3 and I4. Similarly at node B, I5, I6, I7 and I8. First we apply KCL at node A. So sum of outgoing current is 0. I1 plus I2 plus I3 plus I4 is 0. I1 is nothing but, so what is the current here? 25 amps, but this is the direction of our assumed current direction, and original current is opposite. We take a negative value, minus 25, plus I2 is nothing but V by R, so VA by 10, plus I3 and this whatever current given here 5 amp, both are in same, so we take 5 ampere, plus I4 is VA minus VB by 5. Solving, taking LCM and simplifying, we get this equation. Similarly, we apply KCL at node B. At node B, sum of current I5, I6, I7 and I8 is 0. So I5 is nothing but VB minus VA by 5. And here I6 direction what we assumed, and original direction is opposite. So minus 5 plus VB by 2 plus 6. Because here same direction is there, what we assumed I8 and this original current source is having the same. Simplifying, we get the other equation. Solving equations 1 and 2, we get the node voltage VB and VA and VB. So now we are supposed to find the current and power, actually power absorbed by each resistor. So we are going to use the formula I square R. So for that we find the current through the 10 ohm resistor, that is I2 current. I2 is nothing but what? VA by 10. So that we can find, from that we apply the I square R formula to get the power in watts. Similarly, I5 is nothing but VA minus VB by 5, and applying that we get the power across the 5 ohm resistor. Then to find current across 2 ohm resistor, it is VB by 2. So we get the current value, from that the power across 2 ohm resistor we can find. So now let us see one more problem where we are going to find all the nodal voltages given in this circuit. Okay, so here first we mark the node, both the sources are given. First problem we saw with only voltage source, second previous problem we saw only with the current source. Now we are going to see combination of both the voltage and current source, how to solve the problem. So here first mark the nodes A and B, and mark the direction of current I1, I2 and I3. Here at node B, I4, I5 and I6. Now what we need to do, we need to apply the KCL at node A. So I1 plus I2 plus I3 is 0, outgoing current is 0. I1 is nothing but what? I1, and here 10 amp is opposite direction, so minus 10, plus I2 is VA divided by 20, I3 is VA minus VB by 20. Solve and get this equation. Next, applying KCL at node B, VB minus VA by 20, and then VB by 30, then VB minus 150 divided by 15. Solving these two equations, we get the VA and VB. Okay, they are asked to find only the node voltages. Hope you understood how to use the nodal analysis to solve a given problem with only voltage source. Okay, then only current source, then combination of both. Thank you everyone.